Hello everybody, welcome to another stream. How's it going? So last stream we were trying to get the top level BVH by ray tracing against it, but there was a few issues. One was with the quaternion from transform 3D code, so we fixed that. And the other one was that the quaternion packing code was wrong, and it took me a bit to kind of realize it was wrong. Well, no. Yeah, to realize what was wrong about it. But yeah, so it kind of like squishes a bit oddly and it blinks out of existence. Because there's like, when you unpack it, you get the wrong value back. So the reason is because I'm trying to do this technique called the smallest three method. But I'm not actually picking the smallest three component of the quaternion when I'm trying to compress it. So we need to redo the quaternion packing code, and we also need to take more bits as well. So I think we can get away with, we're going to try 10 bits instead of 8 bits per component, and we'll drop the last component and replace that one with 2. So the largest component, where is it? You drop the largest component and replace it with 2 bits to say which one you've dropped, and then you can reconstruct it. Yeah, so I'll leave the links to these blogs in the chat. Well, for those interested. So they're the 2 places where you can find out more about it. So we're going to implement that today. So proper quaternion packing. The other problem is we didn't have enough bits, so we're going to increase the number of bits in the quaternion when it's packed, because I think it would jitter around, or it would stutter when rotating. So we need more bits. And I also figured out. So let's go to the let's open up a new buffer. We'll also open up the shared one. Basically, I realized I'm doing something a little bit silly. This BVH instance basically doesn't need to exist because its center position, half dim, and rotation is exactly the same as the BVH node where it came from in the top level BVH. So I thought I needed it for some reason, and I only need it for when I build the BVH. So if I was to jump back to the shaders, this is the ray tracing traversal code. When we hit the top level leaf, for some reason I fetch out the instance and get the center position of it and the half dims and the rotation, and I sort of bring it back into the local space, which is -1 to 1, by moving the ray origin and the ray direction. But really we already have all of this information. It's up here, the center position, and that here. So we already have all of that. So yeah, we're going to basically rework this. So we're going to get rid of this BVH instance, kinda, and all of its packing code. So that doesn't need to exist anymore, but instead, we're going to replace that with we're going to change it to be instead the BVH build instance, like the build ellipsoid, right? The build ellipsoid is the leaf nodes, the initial leaf nodes, and then it gets built into a full-on tree. So we'll do the same thing here. We're going to have a center position. We could probably pack it better later, but it's getting written once by the CPU and read once by the GPU, so it's probably not worth packing it other than just to save memory. Yeah. So yeah, center position, rotation. So we can really rewrite this a bit. Snorm, unorm, min minus 1, min 0 to 1. Oh. So same thing here. And then unorm. So rotation in this case is going to be a world from, or no, it isn't. It's local. Yes, it's the rotation of what it takes to go into local space of the object. Object from ellipsoid. Well, local from object, maybe. Whereas with the instance, it's world from local. Rotation. So with this ellipsoid, it's more like, what do you call that? So it's going from the ellipsoid, the local space of the ellipsoid to... See, I don't think we need it that way. We might need it the other way around. Let's think about it. So when we're ray tracing, we want it to be stored the other way around. I guess when we're building it, oh, so let's go into shaders. So we use this rotation thing when we build the trees, I guess. Build, not draw. Right, pack. So you get the rotation. Oh yeah. Yeah, so maybe we'll just invert it when we build the tree. So we'll ask for it this way round, where it's local space of the object from object, maybe. From ellipsoid. So the instance now is we'll have a BVH ref to a BVH itself. Right, that's pretty nice. So, right. So now all we have to do is try... So now we've got rid of that BVH instance and replaced it with a BVH build instance, since it was basically pointless. We need to update the arrays where it's used in. So let's quickly go and do that, and then we're going to... Yeah. So we need to do something like BVH instance. So let's look for all these places. Was it search next, wasn't it? Ooh, I don't know if that'll go through there. Right, anyway. So this one is the BVH instances buffer. This is only for building now. Yeah, so these can actually be moved back into this build strut. Instances buffer, and then the next index to bump allocate per frame, basically. We need the building. Neat. So let's go around and correct all those. Oh, well, I could have just done how do I do that? It's that one. Right, so how many of these do we need? Well, it's the number of build leaves, basically. Build leaves instead of, or leaves, as we call it, instead of the total number of instances, right? Just the maximum number of leaves that you can have in a BVH tree. So let's keep going around. So it always is a build instance. This is when we build it. So it's the build instance. Then we build the top level BVH. Build that every frame for now. This one's build instances. Another build instance. So this is going to put in that. Oh, right, I think we're nearly done there. Right, so we just got to change the shader code after that, and this one's the right. So there's like the let's be careful here. So these should all be renamed to build.instances. It's not a valid identifier. Silly LSP. Right. BVH build dot instances buffer ID. Take that. Cool. So save that. Nice. And then there's this thing here which we bump allocate. This one. Oh, I just want to. Nope. Alright, we're all the way around there. So it's BVH build dot instances next index. Neat. So that should have been the CPU side corrected. So let's go back to the GPU side and the shaders. Is there anything in shared, mind you? So BVH instance. Right. Why is that still here? Yeah, we'll come back to the BVH node and correct this. We're not here for that at the moment. So this is the push constants that go up to the shader. Oh, crap. So we don't need instances passed into them. Nice. So let's go back to the CPU side code when we do that instances thing. Equal. Alright, so for packing a quad tree, this is now called build instances. That's corrected now, good. This one is, for the ray trace, we don't need instances anymore. Nice. Right, so that should be corrected. Let's go back to the shader code. Now in the shader code, we've got to look out for BVH instance. So that gets a build instance instead because it's just used for building. Then we get the center position just by doing instance.centerPos now because it's not packed. this one is when we build the tree. So when we build the tree, it's very similar. I don't even know why I need an if statement in this, to be honest. Like, what's this top look? Like, if I just made it the same data structure, then all would be well. So, oh no, I need to know this top level so I can set that thing. Like, yeah, if I made it the same data structure, okay, we'll keep it a separate data structure now because it'll just be effort to change it. But we can have one less buffer. No, you need to have different buffers. No, you wouldn't. Yeah, we could. Yeah, so put to do here. So by this, we'll put to do. Does BVH build instance? Or maybe we should say we should combine BVH. Excuse me. And BVH build ellipsoid. As they are basically identical. And this, or should we and this simplifies some shader code. But yeah, for now it's fine just to keep it separate. So yeah, then we just get the center pos norm. Half dims u norm. I guess I need that multiply. And the rotation is going to be world from local. Whereas this one is local from ellipsoid. Cool, right, so any more of those BVH instants dotted about. So it's just one more. This is when we ray trace a scene when we hit the leaf node of the top level BVH. For some reason, I thought I needed to get the instances when really we already had this information. So I actually don't need to do anything here. We do need an invert. So that's another thing as well. Is like maybe in the BVH node, like when do we use the rotation? Well, we need to use it when we get a successful hit. To rotate it back into proper space. But when we're testing for a hit, we don't need it. So we should only invert it when we need to. So what we should store is a sort of yeah, well, when we repack the node, we'll sort it out. But yeah, we'll invert it and build the tree. It'll be better that way. But yeah, so we don't need any of this. Yeah, we'll always use the inverted one. Alright, so I think what we can do is get rid of all this code. So wait, this BVH node needs to now want a BVH ref. We've got to get that somehow. We'll call it instance BVH ref. So you get all this. Oh, we do need to do the inverse though. That is true. Alright, where's that? Let's re-enable the rotation back, because that was silly of me disabling it. Just for testing. So we need to say local from space rotation. Right, local from space rotation. Good, so it rotates the origin and the direction. So we get the base BVH node index from the BVH ref, which goes into here. And then we push it on the stack. The root node, or root nodes on the stack. Right, that's good. So currently we've disabled this path just so we can debug draw it basically. So we'll keep that around just for now. But when we confident, we'll right, we'll undo that. So this is because I did a bit of a rename. Maybe I should have just done BVH build ellipsoid. And then this is SNORM, short for signed norm, normalization. It's -101. Right, let's compile that and see where we're going. So 3077. Pack the quad tree. So yeah, we didn't do the SNORM thing here as well. So SNORM unorm. Right. Yes. So that thing now, which is 3385, we need to make this function, but let's quickly make it. Wait a minute. Let's go back to where we were. That's wrong, isn't it? This needs to be instance.bvh ref. Excellent. So now we'll get fed into the, wait for it, BVH node initialize, ref index goes into there. So we hop into here, we can now start figuring out shaders. So how many bits we got? 16 bits. There's 2 unused bits. How many bits is the BVH ref? 20 bits. Right. There's things we can do to squish that down to 16 bits. Or tricks we can do. So I think we might as well make a start on repacking this BVH node. Because I'm gonna have to Yeah, let's just go and make all the changes now. So the thing we got to realize, the thing we got to achieve is the following basically: pack all of this data and all this data in a sense. So a BVH node is basically an ellipsoid, and it has an auxiliary piece of information, which should probably only use 16 bits. And then we've got to store basically 9 floats, right? Because you've got 3, 3, and 4 floats, but there's that largest 3 thing you can do where you can use 2 bits for the final field and quantize the rest of them down to a small amount of bits. So we've basically got 9 floats plus 2 bits followed by some 16-bit int. So I want to try and fit into 16 bytes, and I was thinking that's probably not possible. So what we're going to do is split this node into a couple of things. So the reason why it's not possible is because I want to fit the positional data and the position, this half dims, basically scale, and the rotation. Those need to be, we need to have as much precision as possible, I think. We could probably play about with it more in the future. But if we got 128 bits, right? So 16 bytes. To fit 9 floats in, right? So if we're talking about bits divided by 9, it's about 14.2. So if we did, so 14 bits gets us about 16,000 different values for each float, which should be hopefully enough. And it might be too much for rotation, or it might be more than enough for rotation, maybe. But we'll find it out. So if we did that sort of 14 bits times 9, you get 126. Now we do have to store the children count, and we don't have to store the children count. Oh, this is going to be good. This is going to be legit. We can store this children count in the low bits of children node start index, because this is always aligned to 4. I can't believe I already don't do that. I must do that. Do I get a node ref back? Oh, we can get a node ref back. That'd be good. Yeah, we've already got stuff for that. Right, so we can ignore those 2 bits. And then there's 2 bits for the node type. Yeah, so we already needed to add 2 bits on for that quaternion thing. So maybe we can... Hey Voodoo, how you doing? It's been a while. What have you been up to? How you doing, sir? So maybe we'll have to shave off a few bits for the node type, but that's cool. Right, I think we can rework this then. So the way I'm thinking about doing it is storing all of the ellipsoid data in the node structure, and then having another array that runs parallel where it stores data that you only want when you've hit the object, right? Which means if you don't hit any of the objects, you won't bother pulling in any of the data. But the likelihood you're going to hit something is probably quite high. But it's the best I can come up with right now. That doesn't sacrifice. Unless I just make the node structure bigger. Because I could give 16 bits for every... Yeah, maybe we just make the node thing bigger for now. And we can worry about packing it down later and coming up with crazy things. Because we just kind of want it to work at the moment to some reasonable degree with some reasonable degree of performance. So why don't we just say, so we've got 9 floats, 9 times 16. So if I got double, I got 256 bits. So that's 144 bits. Then I can use... I could really just use 20 bits. Yeah, just pack them down to 16 bits each, and we'll see how the precision goes then. Yeah, screw it. Let's do the easy way. So we'll go word 0. We'll do, for crying out loud, 16 bits for center pos y. Released the game on Steam some time ago. Yeah, I saw. Congratulations. How did it go? Yeah, no. It's kind of it's not necessarily optimization, if you will. But yeah, I guess it's done a bit prematurely, but you kind of have to have it done if I want the want it to run fast enough. But we can probably pack it down even more. Center pos Z. So we can have 8 words now. Right, we're doing 8. Yeah. Let's just do that for now. I wonder if I want to mess anything up by changing the size. And I got the stack assert somewhere. But yeah, so half dim. Y. Half dim Z. And then I need the rotation X, Y, Z as well, and then 2 bits for the largest one. So repeat. Great, actually, I have 90k downloads, it's free. Wow, that's pretty good. That's great. Did you get a lot of feedback? Do you have a little community as well, like a little Discord or something? So this be rotation. So this is going to be translate into the local from space, because that's what all you're going to want to do. And then you invert it if you... Yeah, so local from space rotation. Just the other way around, maybe. Y, then local from Z. Right, that's good. So that's all the scalars. We need 2 bits for the... We need 2 bits for the most set bit. Well, I don't have to do that now, actually, thinking about it. Yeah, let's not bother doing that super packing. That'll be alright. We'll just put to-do labels in. Right, so what's left? We need a word for a node type. Word 5, I get up to 7. Word 7. 6. 7. Yes, I guess for now we'll just do something like this. Yeah, it's completely silly, but it'll be good enough. We can optimize it later when we need to make it even better. I'm hoping to be able to squish it down even more. Where's the stack assert? Well, I guess, okay, so put to-do label, right? To-do. Hopefully pack this down to 16 bytes. I think I said bits a second ago, I meant bytes. Down 16 bytes instead of this 32 byte strut. This is so we can fit all 4 siblings of a node into a single cache line. So like we still have the other trick, you know, we still have, right, and I'm gonna write ideas. So the ideas are, remove, you know, we can replace the local from space rotation W with 2 bits using the smaller or the largest 3 the smallest 3 quantization approach. Hey Glorissa, how you doing? Good to see you. Is that one? Glorissa, my BVH node no longer fits in a single cache line. Oh, sorry, all the siblings. I'm just, yeah. I'm just thinking that we need to test out. Yeah. I think we can pack it down into maybe... So right now it's 2 cache lines for all the siblings. So if we do that, maybe going back to a binary tree is better. What? That is for future me to look at, but I think there's still hope to get it down to 16 bytes. Yeah. By reducing some of the precision, because the biggest thing is the precision. So it's like when I move the camera back and I have these entities moving around, is the precision, do we see any stuttering with the rotations or movement, you know, or the scaling? So stuff like that. And I think there's ways we can make it, we can get around this. So the other one is like you know, maybe scaling yeah, maybe scaling could be look into restricting ranges. To offer higher precision with less bits, and we'll give examples. So we could basically say, like with the quaternion, the local from space rotation values will be from minus 0.707 what is this, the square root of whatever in it, 1 divided by square root of 2, isn't it? Yeah, that one, this number. Maths to positive version. Yeah, so instead of minus 1 to 1. Right. Pretty neat. So we can get more precision there. You know, maybe the maybe half dim doesn't need, can be restricted between 0.5 to 1.5. Wait, can it? Or can be restricted in some way? 2. Right, we'll leave that one open. Experimenting with some weird Windows crap. How you doing? Could you just encode mantissa and allow only normalized rotation between 0 and 1? Hmm. I'm not sure exactly what you mean by that. So the mantis is the so the exponent part, which is the thing that is multiplied. The mantis gets multiplied by it, right? So you're saying, so where would you get the exponent from? And then yeah, when we pack it down, we convert it into a signed into unsigned norm value. But you don't get any better precision by doing that, obviously. Yeah, what sort of weird Windows crap have you been dealing with? Is it with the event loop by any chance? Right, I think that's good. So I guess let's do this new packing thing, and we'll yeah. Right, so the other one which we have is that build node ref. Only use 16 bits. What I want. And this could probably only use 16 bits as well, you see. If I don't, because if we align our allocations, so at the moment they're aligned to 4, the node index is aligned to 4. If I just aligned it by 2 extra bits worth, so we're already at 4 extra bits worth, shift right by 4. So we align it to 64 nodes per BVH. If we have at minimum, if it rounds up to the nearest 64, we could then, all the load bits would not be set when you are referring to the first node index. So all those yeah, so these 6 load bits would not be set when you point to the start of a BVH BVH node tree, but you'll be able to address a wider range of nodes. You'll be able to address 24 bits worth of nodes, right? So that's interesting. So why don't we do something like that? I'm happy to do that. So I only use 16 bits, by the way, but can address, we only use 16 bits, but can address 24 bits, but can address as we only address aligned BVH trees, aligned BVH trees. Only address a BVH node that is aligned to 64. Wait, no. There's 22 bits. Yeah, 22 bits. Is always aligned to 64. Is always aligned to 64. So we can pack and unpack into a BVH node, and to save VGPRs in the ray tracer. So that's called double win. This one is so we can pack and unpack. Good day, Lupo. How you doing, sir? Welcome. How are you? I'm doing quite good. I've got to answer Glorious, sir. Yeah, I'm doing pretty good. Yeah, things are going well. It's been at work basically, and yeah, I had end of last week off, so I had a nice sort of long weekend. So feeling quite refreshed. But yeah, back to work now, doing work things. It's going okay. We've just sort of been doing a bunch of planning and things. So yeah, good old Jira, is always aligned to 64 nodes. This is so we can address 22. Yeah, I wonder because if we, the more that we align it, the more space we waste per allocation. This is the problem. This is so we can address 22 bits worth of nodes by only using 16 bits. So each BVH tree will waste some space aligning to 64 nodes. But we should ultimately save space in BVH node and have less cache misses because of this. Yes, I think this is the overall plan, but I've failed to do that here because right now we're just trying to get it to work, but that's the idea at least. We shall see. This is the idea though. So instead we can shift right by 6 because I only need to use 16. Yeah, shift right by 6 since there will be 0 anyway. That's pretty neat. So in the CPU side code, we need to make sure that when we allocate, right? This is another interesting thing in shared. Let's quickly double check the these numbers. Go to look at the numbers. Is there anything that's sort of glaringly wrong which needs to be changed now? Trees, nodes. Number of nodes in a BVH, or a number of build. Total number of BVH. Okay, so that's 26 bits worth. Right. So if I took 4 more bits, which gets me up to align into 256 nodes. So it'd be 256 times eventually 16, so it'd be 4K wasted space. Well, up to 4K wasted space per allocation. Or right now it'd be 8K. Yeah, maybe we'll do the 26 bits, because that gets you 1 gig of... Right, let's do that. Wait, is it right? No, it'd be 24 bits. Yeah, we'll change that number. So align to 256 nodes. Right. Instead, we're going to write a constant because we could change this in the future, right? BVH node allocation align 256. Maybe we just put the comments there. You know what I mean? Like why? Well, I don't know. It's hard. nodes. So 24 bits worth of nodes. You bought melon. Nice. What sort of melon? Watermelon or what's the other one called? I forget. It's probably a few types of lemons. But yeah, I quite like the more white lemon. So refreshing. Put that in the fridge. Yeah, what I've said doesn't make much sense. I think you're doing what I've said already in some way. Okay, that's cool. It's quite expensive, I think. I forget the exact price because I don't buy melon much. My wife does, though. Well, Windows, I have some NVMe SSD. When I'm trying to download a game on Steam, on my Steam partition, goes into read-only mode, and then Windows event, the driver detected a controller error. Oh, crap. The restart everything goes to normal. Oh. That sounds strange. Why don't you, have you tried writing like a big file to it and see what happens if it does that? That sounds bizarre. Because maybe it's getting near the end of its lifetime. How long you had the SSD for? Right, so we aligned to 256. The power of alignment. So we aligned to 256. It means we should be able to support a 24-bit value in 16 bits. Legit. So that needs to be replaced with 8. So really, this should be kind of... we'll call it shift. Right. Rightio. Cool. Oh. Neat. Right, so that's pretty sweet. We're able to pack that now. Oh, we've got to go back into the CPU side and actually make that adjustment. So when we do the allocations, right, we do alloc. I forget these things, right? Alloc. Right, node range allocator block alloc. So here we go. So you must run up to 4 here, but when you allocate in the allocator, not block alloc, you melon. Right, this must be a multiple of BVH node alloc align. Cool. So I just remembered actually quickly, let's jump back into the shared thing because we forgot to change this number. Supports up to 24 bits. So that's, you know what? Let's get rid of that comment for now. It doesn't make any sense. Is that 16 plus 16 plus this, right? Is the addressable amount of nodes. Something like this. Cool, that's very good. So let's jump back to the node allocator. So when we allocate, we ask for a certain number of nodes. So this here says that they have to be aligned to 4. That is correct, because that's the number of children. But we should also round up a line in round up power 2. I don't know why I've got this damn... No, round up a line, which has to be a power of 2. Naming is hard. Yes, we're rounding up nodes count to BVH node align. Nodes count. Right, so that'll do the round up now to 256, which would be pretty cool. So there'll be some wastage there, but that is okay. Well, yeah, so if everything is allocated at 250 or a multiple of 256, then it means everything is automatically aligned. So we don't actually align around yeah. Cool. Right. 3 gigabyte one on Steam. Huh. That sounds bizarre. Yeah, it's the reason why I hate system admin sometimes. Because it's just so complicated, computer systems these days. I don't know how people do it. Especially that system admin on Linux. I just do a fresh install a text editor and a web browser, and off I go. Yeah. Oh, there we go, we're charged now. Right, so now we get back to the fun of the... Right, so we managed to save some bits there, that was pretty sweet. These are 16 bits, this is 16 bits as well. Which is super nice. So now in the... now it means in the BVH node, they only actually just use 16 bits. And again, we've not really tightly packed it because we are going to overflow 16 bytes, unfortunately. So we're just using a 32 byte node for now. But in future, I want to try and fit everything down in 16 bytes. Maybe with an auxiliary array of that. I don't know. We'll see how it goes. So this, if you're a parent node, you get back a node ref, right? You get back a BVH node ref. If you are you get back a BVH ref. Yeah, so if you're top level, you get back a BVH ref. And then if you're bottom level leaf, you get a material index. So, this, actually 16 bits. So only uses the lower 16 bits. Nice. So when we say children count, that one doesn't have to exist either, because children count, you see, is actually stored inside the node ref, because node ref, yeah, we store the children count in the first 2 bits anyway, because they're always aligned to 4. Yeah. No, you won't get 16. You get 14k of addressable. Oh my days. So nodes in a tree. Is actually 16,384. And the reason why we have this limit is so we can store 16. Yeah. Is so we can have BVH node ref be stored in 16 bits. Cool. So that's how many nodes per tree that we support most. We probably can go nowhere near that. That's okay. Right, so let's go back to the node ref, sort this out. So that's fine. So yeah, so I don't need a children count anymore. Just got to be careful when we call node init. We've got to make sure that it is the correct thing is being called. So these, I've never actually used these. I'm gonna get rid of them. They were helper functions to initialize specific ones, but it's never really useful. So let's pop back to the shader code for a sec and correct before we do this, because this is one called children count. It's not really a ref index anymore. What do you want to call it? It's like call it a ref. Right. So okay, here we go. So when we pack the tree, we don't need a children count anymore. We just have a thing called a ref. So if you're a BVH instance, you've already got the thing called a BVH ref. That just goes into ref. Then this material index just goes into ref as well. But if you are not a leaf node, we're going to do something a little bit better. So this is me trying to do some. All right, yeah, this is the quick and dirty packing, and there's me trying to do a better version. But failed at it. So where's the ref at? I guess it's down below. So let's keep going. Right, node index. So ref is going to be equal to that node index. Hang on a minute. What's node index? Oh yeah, that'll be aligned to 4. That's good. Right, so it's aligned to 4. So we just got to say BVH node ref, and then put in the children count in the second bit. So that'd be a value from 1 to 4. Yeah, so then I'll do a take 1. So it'd be a value from 0 to 3, then squish it in the lower 2 bits, which stores a value from 0 to 3. So that will go into there, and the ref will get passed into here and build when we build the node. Right. So now let's get back to the packing business. Go back to the shared header file, and let's just pack everything in here. So we're just doing a very simple packing 16 bits, and hopefully that's enough precision. If not, we need to use more bits, and then we probably can't pack it into 16 bytes per node, and we'll have to stay with 32 bytes per node. So we're going to do the lovely packing stuff here. 65535 is our friend. So it does like a round up a line. Do I want to do round up a line? That's a question. Do I want to do round up a line? Maybe not. Yeah, for a position, probably round up a line. Wait, you want to do like a round? Yeah, a round. It's not round up, it's rounding. So round to, if you're 0.5 or less, if you're less than 0.5, go down. 0.5 or above, go up. Yeah, we'll stick with that. Hey, Mark Kuma. I'm still playing Space Invaders and Barbie. Sorry, wrong window. Okay, good to know. Yeah. Whatever makes you float. So all of them are going to use this rounding. 4, 3, 5. Except for the quaternion. That's another thing with the quaternion. I want to store it backwards. So this should be local from space rotation. So actually, when we do this rotation thingy, this should be called the, I think it's the space from rotation, space from local. And I hate the word local. No, this name's wrong, that's why I don't like it. So in the ellipsoid it should be actually be called space from local. So what the space I'm going to be in, yeah. Right, space from local rotation. So yeah, we're going to set space from local rotation. I don't know why I did that. I can just jump like that. Oh shoot. Well, that failed. Right, space from local rotation. Good. So let's look for this rotation business and figure out. Yeah, we'll change that in a bit. Where is it? Yeah, right. Yeah, so down here, we'll make another quaternion and we'll call it local from space rotation, which is the inverse. So you just invert it. Because when we ray trace against it, we don't actually need. Well, yeah, but then when we get the rotation back out, we'll need to invert it while building it. I think we could take the hit from that. Well, it's only just done a few negates in it. You know what? We're not going to bother doing any of that. That's cool. So space from local rotation. So actually when we... Okay, that's good. Let's go back to the packing code. Shared. So let's quickly just rename that. So local from space. Space from local rotation. Right, so let's get all the packing going. So this one needed to do like a take one, so we could decode 0 perfectly and still get... Maybe we can actually get 1, but yeah, decode 0 perfectly. So that'd be 6, 5, 5, 3, 4. Oh, Makuma. Let's delete that one. I'm sorry, Maxima. That's right, Maxima. Hey there, Zaka? Oh wow, let me pronounce it. Urtazaka. Is that how you pronounce it? Yeah, it's going alright. Last stream was a bit of a struggle, but yeah, the development's going alright. I'm making forward progress. I'm excited to for when we get this done. I think it's going to be awesome. We'll be able to have instances of models, and then we can move on to building an editor around building some models, and yeah, doing other engine-y side things. Taking a little bit of a break from graphics, and then come back to graphics feeling refreshed. And yeah, so it's going good. I think we're settling on some kind of way we're gonna build models. I think like the foundation of the graphics rendering. But yeah, things are going good. How's things going with you? So yeah, I think we'll just do the W as well. We'll save the super packing stuff for a future Henry, future Henry problem. So that's the rotation W component W. And now here we go. Get ready for the packs. So basically we're going to store a lovely X in there, and you know what? X is a dumb name. Let's make it a little bit better. Why is there extra? All right, yeah, those. That's cool. So, pos X, pos Y, shift 16. I will do that. Cool. And we'll do something like this. So this will be pos Z, then half dim X, or dim X, then dim Y, dim Z. Now before I forget, let's up these boys and girls. Thank you, sir. Oh, best viewers. I'm a girl, definitely, when you have to tell everyone that. Right. So space from local rotation. We'll store that in the word 3. So same sort of thing. Rot. Z W. That is 3 and 4. Yep. Then we just store in the first 2 bits of word 5 the type. Very terrible, but it will get the job done. So we're just looking to do something like this. Type. Jobs again. Yep. Then 6 does nothing. We'll just store 0 in there. Terrible, but it will do. 7 is the last word, and this one stores the ref index in the low bits. So for now, we'll just do ref, and hopefully future Henry will pack this down to 16 bytes. I'm holding out for future Henry. So this is it all now packed. Yeah, we'll keep that in. That's very nice. That's still good. Oh no, you need to invert the W as well. And I want to do it on a new line, so we know to remove it. To do remove once. Well, no, we know we'll end up dropping any one of them, the largest one, isn't it? Keeping the smallest 3. Yep. So that's a future thing to solve. So this is all great. Center pause. One of this ain't great. Word 5. Just return word 5, please. Done. So this one is word 0. 0 and 1. 16. 0. And FFF. Now I did different precisions in the previous packing code, and the reason why I changed my mind is because initially I was thinking, like, hang on a minute, I only did a top-down game, so I only need more precision around the X and Y bits, or whatever. But there's also rotation now. So also the X and Z I only need good precision on, maybe. But yeah, or just the X needs the most, and the Y and the Z need less. But I was thinking that because you've got rotation in local space to world space, you don't know which way is the X or whatever. So it's true for probably the top level maybe, but yeah, not for the bottom level. So they've got to be kind of even, actually. 6, 5, 5, 3, 5. Right, so that's the unpack code for that. Let's do the next one. So, well, so this one, word 1, word 2, and word 2. So word 1 at 16. At 0, then at 16. So this is just a multiply by 2 after, and the reason is because our half dims unorm is actually not unorm. We need to change that as well. Has to store 0 to 2 at the moment because of something silly. Maybe we should drop the unorm name. Yeah, let's drop the unorm name. Solves the problem. So we do a line between 0 to 2, half it, and scale it up. Round it up, neat. Cool. So that's good. Next one is rotation. So this is space from ellipsoid, space from local rotation. So we're just going to decode all the different bells and whistles. We're using 16 bits. So we get all those. Hey Kappa. How you doing, sir? How you doing? What you been up to? What? Z. I need to figure out how do you do that in Helix. Remove multi-cursor. They collapse them. Comma should do the trick. Oh, okay, I've changed my comma key to something else. Prior versions. Space, space. Ooh. Well, I've rechanged all my keys. Is it called collapse? Into single cursor. Right, I've not got that bound to anything. Good to know what the naming is. Good to know. Right, so this is at word what? Word 3 and 4. 3, 3, 4, Jeep. So neat. That's right, isn't it? So X, Y is in the higher bits. The return quaternion, but you forgot your cool. So that's the unpacking code there. Children count doesn't need to exist anymore. So now we just get material index out, which is 7. I just should have typed 7. Yeah, no unpacking bells and whistles required. Right, so material index, then do we call it a child node ref? Or children node ref? Yeah, so node ref really points to the children, doesn't it? So when we say node ref, it's probably better if we named it to children ref, because these are the range of nodes that you're looking at. It's a range of nodes. Yeah, it makes a ton of sense. Right, so you'll be able to fetch the children reference. Then you'll be able to fetch BVH children ref. And then you also have to fetch out the BVH. Ref. So instance BVH ref. And that's just a BVH ref node. So that's 16 bytes. Bits, sorry. Nice. So that's cool. Now it's got to change the shader code. I think the build... Yeah, so we just run it, we should be able to start seeing the problems. So nothing called children count here. Sure, sort that one out. Shaders. How's my kid? Nothing much, Henry. Sorry, I was took long for a respond. Was figuring out what to say. That's cool. Don't worry. When I'm watching other streamers, I'll ask a question and I get a response, and then I'll like spend a while writing a paragraph, and then I'll get too shy and then not send it and just delete the whole thing. But yeah, how's my kid? My kid's good. He's now 1. He turned 1 like 3 days ago. This is a lot of fun. It's starting to develop some little bad habits, but overall is good. It's it's quite a lot of fun to pick up and play with, fly him around, tickle him, play with his toys, just be silly. He's really good at imitating. Like what is mischievous things? It starts to just be a bit noisy and shouty when he doesn't get things he wants. He also, when you're not looking, he'll try and climb the stairs. He'll just like crawl over to the stairs and start climbing up. So he knows stuff he shouldn't be doing. Yeah, that's why you're always looking. But he thinks you're not looking, and he's going to climb the stairs. But yeah, like if he sees something that he wants, he'll be like, start crying if you're not giving it to him. Need to curb that behavior. Naughty. Yeah. Just like his mum or his dad. I don't know yet. Not sure yet. This is my first one. Child off dims. Right, so we don't do that unorm thing anymore. And rotation is now named better. Space from local rotation. So yeah. Alright. So now that will take us to the ray tracer. Oh yeah. So 339. So the ray tracer has a stack of BVH children ref. Should I call it children ref? Oh, and I didn't even rename this. Children nodes. Children nodes. Or child nodes ref? I do like making English wrong. Do you want to get the relative index and the count? Yeah, I think it's better. But I gotta go and change the. Right. So relative index for you, count for you. All right. So, yeah. So I halfway kind of renamed some of these things, and BVH children ref, right? BVH child nodes ref. Perfect. Nice. So back in the shader code. Right. BVH child nodes ref. So these are the nodes stack. That's neat. That still works. So this is child nodes ref 0 to 4. I wonder, did we want to change that BVH node? Child nodes ref. Cool, it's fixed. Right, let's go over all these boys and girls. BVH child nodes ref. Cool. So that's just the relative index there. Count. Here's her, sorry. No, I think you must know it's a boy. Alright. It's a boy. So right, things are going alright. We're nearly there, I reckon. So this unorm needs to get dropped. It's not really unorm anymore. This is a space from local rotation. And I think we're basically there. Wait. When you hit a leaf. Oh, we hit a parent. This is it, isn't it? Yeah, this is so dumb. This would be a BVH node. What do we call it? It was a child nodes ref. Passing the node and voila. Right. I think this is it. So this should get us... It will get us rendering a top level BVH, but we won't traverse down into the child nodes yet because I've disabled that pathway, and we'll just render it as a bottom level ellipsoid instead. But as soon as we get the rotations and that are working fine, then we can go back into getting... Right. Nearly there. Let's just sort this out. So unorm. Right. So yeah, if the stream dies, I'll be right back. You know, AMD drivers just crash hard when you crash. Or crash the whole desktop when the shader crashes on Linux, and they haven't fixed it yet. So here we go. Oh, what is this? All right, this is cool. BVH. So this is the Clang compiler. So we need to change. Right, search more for BVH instance. There's a few more places that. So build instance now, my friend. What else? Designated initializer. Right, so 212. Here we go. All of these boys and girls here. So if we simply just do one of them, then we can send a pos norm it. Then we can unorm it. Then we can space to. Oh, okay. Right, space from local. Yes. Right. Here we go. More compile errors. Right, some more of those. 268. Alright, nearly there. Snorm. Unorm. Space from local rotation. Same thing again. Right, here we go. Fingers crossed. Some more still. Seems like we're getting near the end. Oh, shoot. Oh boy. So this is when we make what? Oh yeah, these are when we build a random tree, so we could drag a slider and test. Building basically 4 nodes all the way up to 64 nodes as a little test. And then rotation. Alright, fingers crossed this works. Here we go. No, 3 more errors. Oh. Snorm it. Right. Build instance in it. Ooh. Right, so this is just a strut now. Just a strut. So we return instance and we populate instance. So really, or from local. Oh, it's not what from local, it's actually view from local, isn't it? Oh. What about that? We're doing view space. Well, That's a fail. Then instance.bvh ref noise 1. Alright, let's do that rename quick. Ah, shame. So it's actually view Maybe we can do this, right? Does that work? We'll find out. Worked. Right, game crashes now. No biggies. The allocator fails. There's a shrink 2. Block ID has less nodes than the new shrinked nodes count. No, it don't. And that's more nodes. Right, so we made it so we rounded up the nodes when we allocated it. So, what's it called again? Allocator alloc. Oh. So, yeah, there's a shrink. So round up this int to the nearest 256 nodes. And then, so why does this old nodes? Ensure that is less than. Right, I think these are, has less nodes than the new. What? Did I get my set the wrong way around? So we look at the block that we're trying to shrink. And yes, the wrong way around, isn't it? So have I been doing it wrong the whole time since then? I don't know. So the old nodes count has to be greater than the new nodes count, or equal to it. Yeah, we're going to be, shrinking it. Huh. Right, let's do that one. Hopefully things don't die. Alright, game crashed again. Right, node 1 has less nodes 0 than the new shrink count this. Why does no one have 0 nodes? So what have I done that's caused this to be so silly, right? Yeah, 256 is a power of 2. I haven't changed this allocator much. Right, other than doing this round up a line thing. Because it needs to be round up to 256. So node 1 will be the first thing you allocate. So you would make a new one, then you're trying to shrink it. Yeah, okay, something really dodgy is happening. So let's do one of those breakpoints and just investigate it, because that's very weird. Because no, block 1 would be the one which covers the whole area. Right, it's the first one. And you would then allocate a new block and get block 2. And then you'll be shrinking. You'll be returning block 2. Oh, what is that doing? If it's exact, return block. If not, shrink. No. Oh yeah, shrink block 1. And then it will allocate a new block to put the remainder on. Okay, so that'd be block 2. So did I change the initialization code at all? I think I might have done. I just said make sure it's a multiple of 256. I didn't change anything. Okay. Let's just build it and we'll investigate it with GDB. So, right, your nodes count is 16384 for some reason. Oh, is that the maximum number of nodes? The maximum number of nodes, man. That was not nodes. That's the maximum number of nodes in a tree. Yeah, how did it get that size again? Yeah, get upper allocation, and I didn't do anything, right? Yeah, nodes cap take 4, so... Right. Right, let's follow it through, see what it says. So, yeah, it does the... It gets you a block. And so this is the first free block. And it has quite a lot of nodes in there. Plenty of room. Then we'll get in here. Let's relook at node again. Or block, rather. Right. Then it crashes there. Oh, that blocks count as returns 0. So did I store it in a U16? That's why. Was that I stored it in a U16. What a bugger. No wonder why the code worked before. The U32, isn't it? Right, so that's the reason why that's failing. Okay, I think we're good. So then that'll take the difference. I don't know why that didn't fail in before. Of all the testing that we've done with this, like we've got our own test function, which does like a validation function which validates the whole, make sure all the pointers are pointing correctly and all blocks can be seen and referenced, and yeah, and a test function which goes over and allocates a whole bunch and deallocates stuff. So it's been tested. I can't believe we didn't find that, but okay. And here we go. So we're booted up. Right. So things we're not right. So we're not getting that problem anymore, where things are disappearing. We're still getting an odd rotation thing though, I think. We'll have a look into that. Right, okay, this is good. So, for some reason, something's wrong with our transform. I'm going to figure out what it is. So these are two instances of a bottom level BVH, but we're not rendering the bottom level BVH. We're not going into that object and then rendering traversing that bottom level BVH. We're just traversing the first top level BVH, and when we hit a top level leaf, we're just going to render it as an ellipsoid. And we're doing this so I can test out the code, because for some reason, right, when I rotate the camera, it doesn't look good. Right, this should not be happening. So yeah, we've got to figure out why this squishing is happening. Yeah, so we was kind of getting that last time. Could it be the ray direction? We're doing stuff to the ray direction, isn't it? I think it's correct. Right, so we got a ray tracer. Stallion's brain. Hey, welcome. Oh yeah, what do you mean by reinventing the wheel? I didn't realize we have wheels. Right. So I think this could be to do with ray direction, the squishing, right? Because I think it's being... No, it could be anything. So when we hit the bottom level leaf. Okay, that's cool. Like, you need people to be, to make engines for people who don't make engines to make games. So it's an ecosystem. Let people do what they want to do. So So the way we get ray direction in local space is we take our ray direction in view space, we apply... Oh, we're not squishing it. Where's the squish? Oh no, the squish is here. Yeah. Okay. Ain't making a better thing than 300 people. That's cool. Well, guess what? Tons of games exist. You ain't making a better thing than all those games that other people make. So you might as well just quit while you're ahead. You know? Yeah, so we apply some rotation, inverse rotation to the quaternion, to the direction of the ray. We subtract it back to the center, then apply the rotation of the origin. He was alright. Yeah. It's part of the anti-game engine brigade because a bunch of people think that game engine people are elitists and full of ego, so they try and beat people down who make engines. Let alone those people need people to make engines because if not, they won't be able to make games or make better games. So it's just silly. Here we go. So we could debug draw this like we did before. So we debug draw the ray direction and ray origin in world space, and see how it changes when I move the camera. But we might have to swizzle some of the components. Yeah. Yeah, another thing that guy doesn't seem to understand is like, how do you think those 300 people exist? Do you think those 300 people just exist out of thin air? Like, the 300 people come to existence by writing game engines and learn how to write game engines so they can all contribute to a bigger game engine. Mind blown. This is so dumb. Hey, Emo Giraffe. How's it going? Hey, hey, hey. How are you? I think we're gonna have to debug draw it, which is alright, because we did this before. So it's just if our mouse is at, so the reason why I do this is because we do this per pixel, so I just want one set of drawing results. So we've got a thing called ucoord, unsigned coordinate, and if our mouse is at that coordinate, right, it's a lovely function. It's a good function. We can now do a very limited set of drawing. So what I'd like to do is draw a sphere in world space to represent where. So if I say ray origin local space. Oh my days. This guy's got a very limited understanding. You can tell he's probably not much of a programmer. Like, he doesn't understand what even goes into an engine. He just understands. People spent a lot of time on engine, therefore impossible. Like, definitely not a big achiever. Mm. Yeah, exactly. So you rather like spend time shitting on other people rather than just doing art? Sounds good. Like, there's plenty of custom engines out there, and they do a good job at what they do. Small, tailored to the problem. And if you want to be an engine developer like I am, you better have a portfolio. You better have your own projects. To me, games are art, and the full art of making game starts with the engine. And you use off the shelf engine, you don't climb that mountain. So yeah, I do sort of as a as someone who views games as art, I do also have a very similar opinion like that. Um, I do also find that making your own engine is more than just like if you get control over the code. You can continue to build on top of it over the years. And if you're just building a 2D game, it's actually very simple to build your own engine. If you're building a 3D game, it's a bit more involved, there's more maths. But at the end of the day, it is still possible to build your own 3D game engine and start small. There was that game, what was it called? Penny's Breakaway, what was it called? Big Breakaway. So these guys in a small team made their own engine off of the Sonic Mania engine. 3D game. And they built all their own tools and stuff. Small team. And they built it all in a new programming language. Right. So like, it's possible to do this stuff and still make a 3D game too. And these guys had control where they can make their own tools and do stuff specific for the game and make the workflow nicer. So, when you use an off-the-shelf engine, you're stuck with the build times that you're given, you're stuck with the tools that you're given. You might be happy with the tools, but you might also want them to do other things. And yes, there's a lot of work to build your own engine and tools, but the more skill we have in this area, the less harder it is. The more people we have that just say, oh, it's impossible, the more impossible it becomes, and the less we have people capable to do this stuff. So, if you want your tools to get better, then people building their own engines is a good thing. Oh, also, it gives you control in the sense of politics. If Unity decides to change its licensing agreements, or if Unreal decides to change their licensing agreements, or if they decide to change the code in ways which you do not like, I don't know if you could fork that code legally. Maybe you could keep the version and keep it going, but that's maintaining a much larger code base than you would like to maintain. And also, you get to keep more money if you have your own technology. So there's lots of reasons to roll your own engine. Many reasons. Other than just fun and learning reasons. There's many good reasons. I love writing my own things from scratch and understanding it from the bottom up. Exactly. So yep. Me too. I've seen a few people who don't have the same purist mindset as me that simply say it's worth it for understanding and control. Yeah. No, I do sort of have that similar mindset as you, but I'm also quite I think there's a range of aspects of making an engine that equally have the same value. Um, in my opinion. But yeah, the control is a big one, especially if you're a company. I'm really interested in programs, get started learning bash scripting. Wow. Yeah, I think I maybe would have done some bash scripting then. But when you become a programmer, you realize how terrible shell scripting is. And it's not a very maintainable thing at all. It's very error-prone language. Started learning some bash scripting this some vacation. I'm a medical student. Cool. I wanted to contribute to free software. Nice. The Rift Breaker also runs on its own engine. Very impressive. The Rift Breaker. Oh, is it like a StarCraft thing? Look at all this damn low quality. What is up with YouTube? YouTube's like, hey, we offer 1080p, and then they give you like 360p, which feels like 144p. Always on my phone, I'm like 1080p, and I have to go into an advanced tab all the time. Right, nice. This looks like right. It's just not like an RTS, but it's nice. That looks pretty cool. Looks like I did some great nice effects, lighting effects and stuff. Neat. That looks cool. I like the scenery as well. Nice. Whilst my view is simply the art, I can try to justify the self-development as well, as you're alluding to. You bring more of the world. You bring more to the world, honing your skills this way. Yes, exactly. Yeah, I think like from the start, I was very much the art mindset of like, as an artist, Tony's creating a piece of art. Um, yeah, I want to make the whole thing, right? I don't want to make just part of the thing. I think as I fell more into doing it, the other opinions, the other aspects of it, yeah, became more aware to me. The entropy creeps into big frameworks to where it becomes too bloated and unwieldy. Yep. The skills to know how these things work is very important. Yep. Also, codebases are that are similar, but the myriad of choices along the way. Oh, my thing. Yeah, no two identical. Yep. Yeah, definitely. Like, yeah, if you make the thing and don't just grab a bunch of stuff from the side, definitely. The problem is you don't know what you want to build. I just want to learn coding. Great. Well, there's plenty of projects you can do. Like, the thing is, Bash scripting is not programming. It's basically a system admin tool to help run commands. If you want to do programming, do you want to learn sort of like low level programming, how the computer works? Or do you want to learn more of like the high level stuff, make websites and or C sharp apps? Or do you want to learn like C pointers, the sort of old school low level programming stuff? Doubt spent years building an engine when I could make assets. Yeah. Well, you're a 3D artist. That's how you would do it, isn't it? Customer vision allows you to do exactly what we want in a game without constant fighting with engine developers assuming what you want to do. Yep. Yeah. Like systems that have been designed a certain way, and you need to either do a very hacky implementation or change the API. Tim, thank you so much, sir, for the raid. Appreciate it. How's it going? How you been? Welcome, raiders. We're currently working on ray tracing a BVH in a compute shader. We've got a bottom level BVH, and we're currently ray tracing the top level. We have instances of things, but we're currently getting odd squishing and stretching stuff. As something is wrong with our... Yeah, something is wrong with the way we're doing the transforms. So yeah, we're trying to figure out that one. Meanwhile, trying to combat anti-engine people in the chat. Yeah. But yeah, how did the stream go, Tim? Thank you so much for the raid. Yeah, it's been a while since I've seen your projects. What current project you work on at the moment, Tim? Yeah, so I'm trying to figure out what is going on with... So we're trying to debug draw some spheres and stuff, you know? So if I draw the local space, do I want to let swizzle it? So if I draw it where the X and the Z are swapped, so Z, Y, X, with a radius of maybe 0.1, maybe that's a bit too big. And then like a color of -1, so that'd be white. And then Z test no. So then if we draw the vectors now, so all right. So this is in the shader. We're trying to debug draw. So we've got debug draw API on CPU and GPU. So it just pushes it on the end of a buffer and then draws it at the end of the frame. So we're saying for a single pixel on the screen, just take the geometry we're trying to ray trace and put vectors in the scene of where the ray is in local space. So I want to do it with the ray direction, isn't it? Ray direction, local space, and we'll swizzle it again the same way. Z, yeah. With a bit of thickness, and off we go. So let's try that. I think we may need a... Let's just see how that looks for a sec. I think we might need a... Alright, what's going on here? So there's the ray origin, and then there's the direction. I've swizzled it, so it's gone in slightly different directions. Alright, so up and down works fine. Left, right seems to work fine. What the crap is going on with this one? We ray tracing too many things. So what is can I print this out because I'm just a little bit confused. GPU print. Oh, I've got it out. find it's best to let them use the tools they use, whether it's custom or commercial, as long as it works for them. Yep. Yeah. Ray origin X, ray origin Y. Yeah, so we've seen like 4 of them basically. I don't know what we're doing. Oh, there's too much stuff from CPU. Yeah, there's 4 of them. Right, how are we ray tracing against... Oh yeah, right. There's the uninitialized nodes. Those should be zeroed. Hang on a minute. Maybe we didn't zero the memory. I think we did. The root nodes... Yeah, so I didn't zero all the memory because I changed the size of the thing, didn't I? Right, let's do that. 4, 5, 6, 7. So that's the reason why we get an extra one's being rendered there. I need to kill that. So I think we ignore that one. That big one, we ignore it. It's kind of wrong. But we zeroed everything. Oh, right, then it would have done the quaternion and then... Okay, that's alright. Right, yeah, so the problem is that we only really want to draw... Let's just say n child index is less than 3. And I'll draw something better. No? Sorry, less than 2. Okay, so... There we go. So it's actually drawing 2 sets of these. They're just so close to each other we don't see a difference, but... Right, so in terms of left and right, up and down is kind of wrong. Well... I don't think it would be that I need to flip the Y. So why did it stretch along the X one? Right, let's draw the... Let's make it a bit far thinner. Let's draw another sphere to represent the the local space object of let's draw over color red. A local space object of the ellipsoid. Right, maybe we should bring that a bit closer because I can't. Alright, I can move closer to it. But yeah, as you see, I'm moving in space. It moves closer to the object, right? And then right. Let's move it a little bit closer. So if we maybe subtract a bit of let's subtract a bit of like on the Z. See like a -1 maybe. And that should be close to the camera. Hopefully that's close to the camera. That's further away, isn't it? Well, let's drop the minus. And then this also needs to be at 0, 3. Oh, I subtracted, right, and a double negatives, didn't I? Of course. Right, okay, good to know. -3. Okay, so now we're seeing it a bit closer, at least. See, I should really be able to like freeze it and then move my camera and get a better angle maybe, but so right, it's rotating around the local space of the I think that's right. See when we rotate the camera, it's rotating the camera itself round its own origin, right? I can't see it move itself because we're in the local space of this object here, which is the ellipsoid. So the ellipsoid will be in 0, 0, origin 0, 0. So when we rotate the camera, what should it be doing? It should probably be rotating itself around. No, should it be? No, right. If we move the camera, it would be should orbit itself around. Right, I'm seeing what's happening now. But what should be the desired behavior? Vertical strips of binary. These are the Morton codes. So each leaf node is an ellipsoid. This is the test tree that we can't see right now. But each leaf node is an ellipsoid, and its position. This is its Morton code position, positional data. So if you take the X, Y, Z and squish it into a 32-bit Morton code. That's what you get. Hey, Call Zero. Submit a custom Bezier curve implementation in Godot for the purpose of extruding a shape along the curve. Only to learn that Godot already has a curve class and separate class that supports extruding a shape along it. Ah. Nice. Pretty cool though, you made it. It's good learning exercise. Yeah. Yeah, exactly. It's another reason why to implement stuff, is so you can do stuff in ways it's not supported. So it's a vector towards there. Maybe I'm not rotating it properly. Alright, let's have a think. I think we're getting close to understanding what is going on. So, non-monitor, that one. So if we have, so in view space, we've got the camera, and then we've got our ellipsoid. That we're ray tracing against. But then like we have but then like when we're ray tracing against it, we actually do the other way around, where we, rather than having the origin here, we have the origin here, and we have a vector going towards, so rather than have a vector that goes towards the center position of the object, instead we have a, damn it, it's so big. We have a camera where the origin is here, and this position is represented by a vector going towards there. So when you have some level of rotation, the hope was that you rotate this vector after, right? So you do the subtract going to ray origin from center position, local from base rotation. What have I done that's so silly? See, when I don't... Oh no, you always rotate first when you're coming out of a... But when you go back in, you rotate... Yeah, sorry, you always rotate... No? Right, let me swap these around and see what's going... See... So if I were to do it this way instead... I doubt this is right. Maybe I'm wrong. It can't be right. Crying out loud. Right. Definitely feels wrong. Like... Could you have to... Yeah, it's rotating itself around the object now. Maybe it was fine. Cool. That's what I'm working on. I'm trying to figure out why when I move the camera my sphere or my ellipsoids get squished. They should not be getting squished. So I'm debug drawing each ellipsoid as a white ball with the... Sorry, the ellipsoid is here and the camera's right. So because you're drawing two cameras on one ellipsoid rather than two. So the way to explain it is that this is where the camera would be in the local space of the object, and because the balls are a little bit separated, the camera would be in two different spots when we ray trace against each ellipsoid. So the ellipsoid is at 0, 0, 0, and the cameras are relative from that. So this is where the camera is relative from each ellipsoid when ray tracing against the ellipsoid. And the arrowhead is the center ray direction. So I wonder if it has to do with the way the camera squishes the 3D scene into a 2D plane to be displayed. No, it's nothing to do with that. It's something to do with my maths code. Because it worked fine before. But I've changed something. And it broke it. So what could it possibly... So when we turn the camera, what do we expect to see? Well, so from the local space of the object, you just expect to see the camera pivot, right? Then when the camera moves, you just expect it to move, right? So it does look okay. I wonder whether it's to do with the half dims or something like this. Like, if I were to scale this by half, what does it do? I just want to gauge what is going on. See what it does. It maybe just half the effect that's going on, isn't it? Yeah, it's still... Yeah, it doesn't do anything. Maybe I need to squish ray direction down. In that case I need to squish... Yeah, but then I would just make it a circle. It used to work fine before we added the rotation. So is the rotation possibly not being built up correctly? We can test this. So we'll call it GPU quat. With a bit of W. So base from local rotation. We'll get a W in there as well. Okay, so CPU side, we already have some printing doing this. Right, so printing out like quaternion, and some sort of weird packing stuff, which we don't really need to do anymore. So if we just print out rotation, what's strange is I see this rotate. Why am I seeing this rotate when the camera's not moving? Like, I'm not seeing any different printing. So why does my ray direction end up rotating when it comes to so I thought we the view from local matrix doesn't, the view from world matrix doesn't change when I move, when I'm in this mode. Hence why the camera doesn't move. But, and then also when I print it out, I'm not seeing anything. When I print this out, I'm not seeing anything change in the terminal. But then when I obviously do this, the numbers all change. Oh, that's because it's using the right. Yeah, that's because it still updates the rotation. Wait a minute. So I print this out and it's still like it's anything that gets fed in. But the world from view. I'm super confused. How do the values not change? Not really a problem to solve, but why is this happening? So we pull it out from the node. So ray origin is set to 0, 0. Ray direction is set to basically shooting through the pixel in view space. It's not changing based on how I move the mouse. We set these up here. They don't get changed this code never runs because it's and 0. So the only time, so they never get changed. So then this one is equal to by rotating the ray direction. But then we print it out. We're not seeing it change. But we're seeing the ray direction change. As a result, we should... the values are not changing, but if I move the escape, they will change. Right, and they look to be a bit different. Yeah, there's definitely a rounding down, but that's fine. Oh, the quaternion is definitely wrong. Is that right? Yeah, that quaternion looks a bit wrong. Oh no, it doesn't. It's all negated. Yeah, we should look at that negate code. I don't know if that negates things causing a problem. But yeah, the values are basically the same. Yeah, I'm curious, so why is it doing that? So this time it's print out. Super confused right now. So what ray direction printed out now? So if we freeze the camera, do we see that value update in the terminal? Wait. Yes, and that value updates in the terminal. Let's move the window a bit so we can see it. How? Ray direction is literally just multiply. Is this just like invalid? It can't be invalid data. Like how? Like we're printing out. Like that's just as you didn't take away. You know, just in a negate. So. Alright, let's change this to the other one. Local from space, which is just the inverted version. See all the crap is going on there. And the answer is that quaternion doesn't even change either until I do this. And then it's just an inverted version of the quaternion. I'm not restoring the W at the moment. Yeah, I removed that. Because one, it was wrong. The technique advises you pick the largest value and keep the smallest three. Find the largest value, discard it, keep the smallest three, and use an extra 2 bits to figure out which one you've discarded and reconstruct it that way. But that's gonna be more code, so I just got rid of. I didn't do that for now. I wanted to try and make it bug free first. Yeah. But yeah, I need to double check in that, but still though, we're printing them out. This value is different. It changes. Why? Oh, I know why it changes. I'm an idiot. I'm an idiot. I'm using mouse at. So obviously when my mouse moves, I'm gonna get a different value for redirection, obviously. So therefore it's gonna draw the rotated one, which could also be the reason why. Okay. My debug visualization could be slightly wrong. Then. Because it's rotating it twice. Maybe. Oh my days. That is weird. Yes, I'm interested in seeing so instead we want to save coordinate dot x. What's the halfway? What is temp? Temp display width is 1600 by 900. So half of that is 800. So we don't have screen resizing right now because we've just not really needed it. 450, isn't it? Right, so that'll be better. So we move the camera now. Behaves better. Should get more of a bird's eye view on it. So we'll do a bit of a swizzle. So what we want to do is swap the so the y needs to go along the x component. So it'll then be yzx. Doom, 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 doom. Right. That's not what I wanted. So we swap the x. Wait, what do I want? So I want it to be such that the z points down the x. Wait, the z points down the x, and the y points down the z. Negative z though. That's all right. Yeah, so it's that. Right. So see, it's like a top downer. There we go. So right, we move the camera to the left. So initially the center of it is going through do we need to flip the coordinate? Because like so the center of the screen is going through the right. Oh yeah. Maybe it's going around that hand. This one and this one. Yes, we would. Okay, so if we move. So move to the right. The center of the screen is gonna. Should go through. The problem is this is not drawn to scale, so it's quite difficult to tell if that's true or not. But yeah, so Yes, this is obviously wrong, this red, the size is red one. So it would still go looking through the ball, and in this case it would have, so you can tell that this line here represents the right ball, because it's missed first, right? No. This line here represents this ball. Or this ray is for this ball here. Because it's still on the other one. So yeah, it's on the right hand side, then it's missed it. Hmm. So if I change it around the other way, it's just gonna invert the rotation around the other way. Let's check my unpacking code and packing code for the rotation and stuff. Make sure that's right. So we take the rotation x, y, z. It's -1 to 1. We've flipped it here. We don't really need this flipping code anymore. I doubt that's gonna change anything. Yeah, we compress it down. Make it 0 to 1. Compress it down. Right. We store rotation x, y, word 3, z, w, and 4. Yeah, so we just unpack it like that. That's good. So if we printed out the values as well so we can compare them, and they did look fine. So yeah, we just compared GPU 1, that's obviously the one on the GPU, versus one on the CPU. The GPU 1 is going to be rounded down a bit more because it does truncate. But yeah, that does look fine. Let's just move it around a whole bunch. Yeah, it appears to be truncated a little bit, but that again is fine. So yeah, I think we're translating that the quaternion okay. So it must be something to do with this rotation still. We have played around with converting a transform into a quaternion and then applying the rotation. And we did fix that, I believe. Yeah, this is something a bit silly, but I'm not sure what it is. Right, so I guess I'll put a pin in it for today. So we made some progress by sorting out the BVH node and instance structures, so they're now in a giving us back correct values, so things are not looking so weird, like things are not disappearing. But something's still a bit wrong with the way we're transforming the ray origin and ray direction. And it was working fine before we added rotation, but now we've got rotation and something's wrong. So we'll investigate that further next time. And then hopefully when we got that working, we should just be able to try and optimize the shader a little bit. So that will be Thursday's stream at 7:30 p.m. GMT+1. Right, let's find somebody to raid. There's a Discord if you come and hang out in the meantime. And if you follow that link there, if you're a subscriber via Twitch or support via Ko-Fi, you get access to the source code and you can run it on your local machine. Yes. There's also a YouTube channel where you can follow. Awesome. Yeah, it's good, man. It's good. Actually made some progress today. I was happy about that. Just these damn rotations. But yeah, we'll get that sorted out. But yeah, there's a YouTube channel for recaps if you want to watch the devlogs. There's a VOD channel we're going to catch previous full streams as well. Available there. Memory battles. Let's do it. Right, I'm going to go and eat some food, exercise, that sort of stuff, and then crash out in bed. Right, have a good Wednesday. I'll see you all Thursday, hopefully. Bye-bye.